Q3338. If the pilot experiences ground resonance and the rotor RPM is not sufficient for flight. A. Open the throttle full and lift off. B. Apply the rotor brake and stop the rotor as soon as possible. C. Attempt to take off at that power setting. The correct answer is B. If the pilot experiences ground resonance and the rotor RPM is not sufficient for flight, the appropriate action is to apply the rotor brake and stop the rotor as soon as possible. Ground resonance is an uncontrolled oscillation of the helicopter's rotor system and can occur when certain mechanical or aerodynamic conditions are met. It can cause severe vibrations and potential damage to the helicopter. Applying the rotor brake and stopping the rotor helps to quickly dampen the oscillations and prevent further damage. 2329. If ground resonance is experienced during rotor spin-up, what action should you take? A. Taxi to a smooth area. B. Make a normal takeoff immediately. C. Close the throttle and slowly raise the spin-up lever. The correct answer is C. If ground resonance is experienced during rotor spin-up, the pilot should close the throttle and slowly raise the spin-up lever. Ground resonance during rotor spin-up can occur if there is an imbalance or misalignment in the rotor system. By closing the throttle and raising the spin-up lever slowly, the pilot can minimize the potential for ground resonance to develop further and safely address any mechanical issues before attempting to continue the rotor spin-up or flight. 3733. With calm wind conditions, which flight operation would require the most power? A. A right hovering turn. B. A left hovering turn. C. Hovering out of ground effect. The correct answer is B. During a hovering turn to the left, the tail rotor is working harder to counteract the torque produced by the main rotor rotation and maintain the helicopter's heading. This increased workload on the tail rotor causes it to absorb more engine power, which can lead to a decrease in overall engine RPM if throttle is not added to compensate for the increased power demand. On the other hand, during a hovering turn to the right, the workload on the tail rotor is reduced as the torque produced by the main rotor rotation is partially countered by the turn itself. This results in the tail rotor requiring less power from the engine, which can cause the engine RPM to increase if throttle is not slightly reduced to match the reduced power demand. In both cases, it is important for the pilot to monitor and adjust the throttle to maintain a proper balance of power between the main rotor and tail rotor, ensuring stable RPM and control during hovering turns. 3734. If the pilot were to make a near-vertical power approach into a confined area with the airspeed near zero, what hazardous condition may develop? A. Ground resonance when ground contact is made. B. A vortex ring state condition. C. Blade stall vibration could develop. The correct answer is B. If the pilot were to make a near-vertical power approach into a confined area with the airspeed near zero, a hazardous condition that may develop is a vortex ring state condition. A vortex ring state, also known as settling with power, occurs when a helicopter descends vertically into its own downwash. It is characterized by a loss of effective translational lift and a rapid descent rate despite high power being applied. This condition can lead to a loss of control and potentially result in a hard landing or crash. 3734-1. A fully developed vortex ring state may reach a rate of descent that approaches A. 4,000 fpm. B. 6,000 fpm. C. 8,000 fpm. The correct answer is B. A fully developed vortex ring state, also known as settling with power, is a dangerous condition in helicopter flight characterized by unstable pitch and roll oscillations. In this state, the helicopter experiences a loss of effective lift and has limited control authority over its collective pitch control. The descent rate during a vortex ring state can be extremely high, reaching up to 6,000 feet per minute if allowed to develop unchecked. The vortex ring state occurs when a helicopter descends too rapidly while maintaining a high power setting, causing the helicopter's rotor wash to recirculate within its own downwash. This leads to a loss of lift and turbulent airflow around the rotor system, resulting in the uncontrollable oscillations and loss of control authority. It is crucial for helicopter pilots to recognize the signs of a vortex ring state, such as excessive sink rate, uncontrollable pitch and roll movements, and a lack of response to collective inputs. Immediate corrective action, including a significant reduction in collective pitch and/or lateral movement to escape the recirculating rotor wash, is necessary to recover from this dangerous condition and regain control of the helicopter.